Good morning student. இப்போ நம்ம பார்க்க போகிறது example 7.46. Prove that the function f of x equal to x square plus 2 is strictly increasing in the interval 2, 7 and strictly decreasing in the interval minus 2, 0. So that means they ask about that. They ask the questions that they give the one function f of x equal to x square plus 2. So now we in this problem we will prove this function is strictly increasing in the interval 2, 7 and strictly decreasing in the interval minus 2, 0. So now first step I write the given function. The given function is f of x equal to x square plus 2. So I write it here, f of x equal to x square plus 2. In the next step I take the differentiation. So f dash of x equal to differentiation of x square. We differentiate the x square. So 2x. Differentiation of 2 is constant is 0. So 2x. Here the 2x is positive sign. So positive sign we represented by greater than 0. So greater than 0 in the interval 2, 7. So you see this interval. So 2, 7 means it is all the numbers are positive. So we substitute 2, 7 and the x taken between the values 2, 7 means 3, 4, 5, 6. So the between the values 2 and 7 in the between values only taken. So all the between all the values are positive. So any positive values I substitute in the function, in the differentiation function. Again the values, the answer comes to positive. So positive means it is greater than 0. Therefore f dash of x equal to x greater than 0 in the interval. Next f dash of x equal to 2x less than 0. I represent less than 0 because the x I taken from minus 2 to minus 2, 0. So the interval is minus 2, 0 means the values taken minus 2, negative values. There is a negative value. Suppose I substitute the, that means before all the values in this interval is negative values only in the interval, no positive values. So any negative values I substitute here, our answer comes to negative answer. So negative means it is represented by less than 0. Therefore f dash of x equal to x less than 0 in the interval minus 2, 0. Therefore I conclude that f dash of x is strictly increasing on 2, 7 and strictly decreasing on minus 2, 0. Next example 7.47. Prove that the function f of x equal to x square minus 2x minus 3 is strictly increasing in 2, infinity. That means we will prove this function is strictly increasing in this interval. So first I write the given function f of x equal to x square minus 2x minus 3. Next step I take the differentiation. So f dash of x equal to, I differentiate the above the given function. So f dash of x equal to differentiation of x square is 2x. Differentiation of 2x is minus 2 into differentiation of x is 1. Differentiation of constant is 3 is and constant. Differentiation of 3 is 0. So 2x minus 2 I tell it is a greater than 0 in the interval 2, infinity. Why it represented greater than 0 means 2, infinity all the numbers are positive. So I substitute any positive numbers in this function. Again we get the answer is positive answer, no negative. So positive answer we represented by greater than 0. Suppose I take the x equal to 3. X equal to 3 means I substitute here 3 2s are 6. 6 minus 2 4. 4 is a positive answer. I represented by greater than 0. So greater than 0 means we conclude that it is the function is strictly increasing. So therefore from this equation, from this step, this f dash of x I represented by greater than 0. From this I conclude that f of x is strictly increasing on 2, infinity. Next example 7.48. Find the absolute maximum and the absolute minimum values of the function f of x equal to 2x cube plus 3x square plus 12x on minus 3, 2. So you see the question, find absolute maximum and absolute minimum. They ask about the absolute maximum and the minimum values of the function, this given function in the interval minus 3, 2. So first step I write f of x is continuous on minus 3, 2. The second step I write the given function f of x equal to 2x cube plus 3x square. Here the given equation is x cube, that means 2x cube plus 3x square minus 12x. There is a minus sign, minus 12x. So the given function is 2x cube plus 3x square minus 12x. Now I take the differentiation. F dash of x equal to 2 into, I differentiate the x cube, 3x square. So 6x square plus 3 into, I differentiate the x square. differentiation of x square is 2x, 3 into 2 6x, minus differentiation of x is 1, so minus 12. So next step I take f dash of x equal to 0. F dash of x equal to 0 means 6x square plus 6x minus 12 equal to 0, so divided by 6. So x square plus x minus 2 equal to 0. Now I factorize these equations. That means I take the 2 and the minus 1. I add these two numbers, I get the answer 1. So next I multiply 2 and minus 1, I get the answer minus 2. So I factorize this equation by x plus 2 into x minus 1 equal to 0. The next step I take x plus 2 equal to 0, x plus 2, and next factor x minus 1 equal to 0. So x equal to minus 2, 1. So this minus 2 and 1, both the numbers lie in the interval, because minus 3 and 2, the between values are, that means minus 2, minus 1, 0, 1. So these are the between values. So minus 2 and 1 in the lie in the interval. So therefore the critical points are x equal to minus 2 and x equal to 1. And next I take the end points. The end points, you see the interval here, the end points are minus 3 and 2. So x equal to minus 3 and x equal to 2 are end points. You see there is x equal to minus 2. I substitute here f of minus 2 in the I substitute x equal to minus 2 in the given function. So f of minus 2 equal to 2 into minus 2 whole power 3, 3 into minus 2 whole square, minus 12 into minus 2. Therefore f of minus 2 equal to, that means minus 2 whole power 3 is minus 8, minus 8 into 2 minus 16 plus minus 4 into 3 12 plus minus into minus plus 24 equal to, that means 36. 36 minus 16 is that this is 12 plus 24 is 36. So 36 minus 16 is 20. Next, when x equal to 1, f of 1 equal to 2 power 1, 2 into 1 power 3 plus 3 into 1 square plus 12 into 1. Therefore 2 plus 3 minus 12. 5 minus 12 is minus 7. Next, x equal to minus 3. F of minus 3. F of minus 3 is 2 into minus 3 whole cube plus 3 into minus 3 whole square minus 12 into minus 3. So minus 3 whole 3 means, that means minus 8. That means minus 27. Minus 27 into 2 minus 54. 9 3s are 27. Next minus into minus plus 36. Therefore if we add all the numbers, we get the answer 9. Next, x equal to 2. So I substitute x equal to 2 in the given function. Small f of 2 equal to 2 into 2 power 3 plus 3 into 2 square minus 12 into 2. Therefore f of 2 equal to 16 plus 12 minus 24 equal to 4. So you see we find the 4 values, 20, minus 7 and 9 and 4. Among these 4 values, the biggest answer is, biggest value is 20. So 20 I take an absolute maximum, and the lowest value is minus value is the lowest value. So I write it minus 7 is absolute minimum. Therefore absolute maximum is 20, absolute minimum is minus 7. Now we discuss about the example 7.49. Find the absolute extreme of the function f of x equal to 3 cos x on the closed interval 0, 2 pi. So f of x equal to 3 cos x. Therefore f of x is continuous on 0, 2 pi. So now I differentiate the given function. So f dash of x equal to 3 into I differentiate the cos x. Differentiation of cos x is minus sin x. So minus 3 sin x. Next step I take f dash of x equal to 0. So f dash of x equal to 0 means minus 3 sin x equal to 0. So sin x equal to 0. So sin x equal to 0 means x sin pi is a 0. Sin pi we get the answer is 0. So we write it, that means sin x equal to sin pi. So a sin cancelled, x equal to pi belongs to 0, 2 pi. Therefore the critical point is x equal to pi. When x equal to pi, so the function is f of pi equal to, I just substitute cos pi. So 3 into cos pi. So cos pi is a minus 1. 3 into minus 1 minus 3. Next x equal to next I substitute the end points. End point is x 0, 2 pi. So x equal to 0, x equal to 2 pi. So next I take x equal to 0. So f of 0 means 3 into cos 0. Cos 0 is 1, 3. X equal to 2 pi. So 3 into cos 2 pi. Cos 2 pi is 1. So 3. So among these 3 values, so we find out the 3 values. One is minus 3 plus 3 plus 3. So among these 3 values, the highest value is 3. So the absolute maximum is 3 and the lowest value is minus 3. So we write minus 3 is the absolute minimum. Absolute minimum is minus 3. So we complete the, you see the question, that means the question asks about find absolute extrema. Absolute extrema means we find out the absolute maximum and absolute minimum. This is a question for in this problem. So we find out the answer, that means absolute maximum is 3 and absolute minimum is minus 3. Next, example 7.50, find the intervals of monotonicity and hence find the local extrema for the function f of x equal to x square minus 4x plus 4. That means they ask about the intervals, and next they ask about the local extrema. Local extrema means that means absolute maximum and extrema means maximum and minimum. So local maximum and local minimum we find out for this problem. So first I write the given function, that means here small f of x, not f of capital F of x, small f of x equal to x square minus 4x plus 4. So small f of x equal to x square minus 4x plus 4. Next I differentiate the given function f dash of x equal to, I differentiate the x square 2x minus 4 into I differentiate the x. So next step I take f dash of x equal to 0. So 2x minus 4 equal to 0, 2x equal to 4. So I write the 2 in the denominator right hand side. So 4 by 2, 4 by 2 means 2. So x equal to 2. So therefore the stationary point is x equal to 2. So I represent this x equal to 2 in the number line. So I take the limit minus infinity to plus infinity. So I represent the 2. Therefore the intervals are minus infinity comma 1, next 2 comma minus infinity comma 2 and 2 comma infinity. This is the interval. So here 2 will come, minus 2 comma minus infinity comma 2 and 2 comma minus infinity. These are interval. Next I make the table. Interval, first column interval, second column sign of small f dash of x, next monotonicity. So interval means minus infinity comma 2, 2 comma infinity. So sign of f dash of x is, so I substitute any value from this interval, I get the answer minus x. So minus value, minus answer. So I represent it strictly decreasing. Minus means it is strictly decreasing. Next suppose I substitute, I take x equal to 1, that value I substitute in the f dash of x, small f dash of x, it gives the negative answer. Therefore here I represented strictly decreasing. So next I take any value from this interval. Suppose I take the x equal to 3 and I substitute in the f dash of x, it gives the positive answer. Therefore I represented strictly increasing. Therefore f of x is strictly decreasing on minus infinity comma 2 and strictly increasing on 2 comma infinity. Therefore that means the above tables, from the above table I conclude that f of x is strictly decreasing on minus infinity comma 2 and strictly increasing on 2 comma infinity. So from the above table I tell this line. Next since f dash of x changes from negative to positive, yes, here you see the sign minus to plus, sign changes. So sign changes means there exists a local minimum at the point x equal to 2. Therefore you tell the changes from negative to positive when the passing through x equal to 2. Therefore f of x is local minimum at x equal to 2 and the local minimum value is, so local minimum is x equal to 2. So we find out the local minimum value. Minimum value means we just substitute x equal to 2 in the given function, f of 2 equal to 2 square minus 4 into 2 plus 4. Therefore 4 minus 8 plus 4, we get the answer 0. So this is the local minimum value equal to 0. This is the answer. Example 7.51, find the intervals of the monotonicity and hence find the local extremum for the function f of x equal to x power 2 by 3. So you see find the intervals of the monotonicity, that means they ask about the intervals, and next find the local extrema. So for the function, so first I write the given function f of x equal to x power 2 by 3. So next I differentiate the function f dash of x equal to, that means I differentiate the power 2 by 3 into x power 2 by 3 minus 1. Next I differentiate the base, definition of x is 1. So therefore in the next step 2 by 3 into, I just in the power I doing the cross multiplication, that means 2 minus 3 into 1 3. So 2 minus 3 by 3, 2 minus 3 by 3 means minus 1 by 3. So therefore 2 by 3 into x power minus 1 by 3. Therefore f dash of x equal to 2 by 3 into x power minus 1 by 3. Therefore f dash of x equal to, you write it, f dash of x equal to, you see, not equal to 0 for all x. F dash of x does not exist at x equal to 0, because suppose I substitute x equal to 0 means this x power minus 1 by 3, we write it 2 by 3 into 1 by x power 1 by 3. So I substitute x equal to 0 means 1 by 0 is infinity. So we can't define it is greater than 0 or less than 0. So it is so we can't, it is not, does not, so f dash of x does not exist at the point x equal to 0. So next, there are no stationary points, but there is a critical point. So critical point at the point x equal to 0. Therefore now I make it the column table. The first column is interval, second column is sign of f dash of x, third column is monotonicity. Monotonicity means it is we represented the strictly decreasing or strictly increasing function. So interval means I write the interval here. The number line is, that means minus infinity to plus infinity. The interval I represented 0 in the middle, so minus infinity to 0 first interval, next 0 to infinity. Now I substitute any value from this interval, so all the values are negative. Suppose I take the x equal to minus 1, so x equal to minus 1 I substitute here. So I substitute here means f dash of x equal to 2 by 3 into 1 power minus 1 by 3. So I put it to 2 by 3 into 1 by 1 power 1 by 3 equal to, so that means 1 power minus 1 power, that means otherwise I substitute the x equal to 2. So x equal to 2 means 2 by 3 into 2 power minus 1 by 3. 2 power minus 1 by 3 means x 2 by 3 into 1 by 2 power 1 by 3. So this is the, we get the answer negative. So from this we so negative answers, so strictly decreasing. Next 0 to infinity, so we substitute, that means we take the x equal to minus 2. X equal to minus 2 means we get the negative answer. X equal to minus 1, all the, in this interval all the values are negative, so I substitute any negative values in this interval, in this function, we get the negative answer. So minus, so 2 by 3 minus 1 whole power minus 1 by 3. So therefore the minus strictly decreasing. And next in this, from this interval here all the values are positive, so I take x, suppose x equal to 1 I represented here. X equal to 1 means it gives the positive values, so positive. Therefore minus, I tell that it is strictly decreasing, plus I tell that strictly increasing, that means minus sign I take that strictly decreasing, plus I take that strictly increasing. So f of x is strictly decreasing on minus infinity comma 0 and strictly increasing on 0 comma infinity. Therefore f of x changes from negative to positive, so passing through x equal to 0. So negative to positive means we consider local minimum, so local minimum equal to, at the point x equal to 0 we substitute the answer in the function, we get the answer 0. Therefore local minimum value is 0. Next example 7.52, prove that the function f of x equal to x minus sin x is increasing on the real line. Also discuss for the existence of local extrema. So you see the question, prove that the function is increasing. So we will prove that this function is increasing on the real line, and also discuss the existence of the local extrema. So now I write the given function f of x equal to x minus sin x. So suppose we tell about the increasing or decreasing, first we take the derivative. So now I differentiate the function. So f dash of x equal to, I differentiate the x 1 minus differentiation of sin x is cos x, and next f dash of x equal to 1 minus cos x. I represented greater than or equal to 0. So f dash of x equal to, that means equal to 0. So now I take f dash of x equal to 0. So 1 minus cos x equal to 0 means cos x, this minus x I write in the right hand side. So 1 equal to cos x, I reverse the equation, cos x equal to 1. So cos x equal to 1 means 1 I represented the cos 2n pi. Cos 2n pi is 1. So cos x equal to cos 2n pi. Cos cancelled. So x equal to 2n pi. So x equal to 2n pi. So f of x is increasing on the real line because I represented the greater than value. Because so any I substitute, suppose x equal to 0 means cos 0 is 1. So any values I substitute here, I get the positive answer. So greater than or equal to 0. So therefore f of x is increasing on the real line since there is no sign change in the f dash of x. when passing through the x equal to 2n pi. X equal to, suppose I take the n equal to 1 means 2 pi, n equal to 2 4 pi, so 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, any values I substitute here, I get the only positive values only. I get the answer positive answer, no negative answers. So from this I conclude that there is no sign change in the f dash of x when passing through x equal to 2n pi. Therefore n belongs to z. By the first derivative test there is no local extrema. So from this no sign change, no sign change means so no local extrema, I conclude that. So next example 7.53, discuss the monotonicity and local extrema of the function f of x equal to log of 1 plus x minus x by 1 plus x, such that x greater than minus, here minus 1 will come, x greater than minus 1, and hence find the domain where log of 1 plus x greater than x by 1 plus x. So discuss the monotonicity. Monotonicity means the function is straightly increasing or decreasing, and local extrema of the function, and they ask about the domain. So first I write the given function f of x equal to log of 1 plus x minus x by 1 plus x. In the next step I take the derivative, so differentiation the function. So f dash of x equal to, I differentiate the log, differentiation of log x is 1 by x, so 1 by 1 plus x minus, I differentiate the this function u by v means 1 plus x whole square into 1 plus x, I differentiate the x, definition of x is 1, minus x into, I differentiate the denominator, definition of denominator is 1. So x equal to 1 by 1 plus x minus, now 1 plus x minus x plus x minus x cancelled, so 1 by 1 plus x whole square. So in the next step 1 by 1 plus x minus 1 by 1 plus x whole square. So now next step, now I take the LCM 1 plus x whole square. So in the first term I converted into 1 plus x whole square, so I multiply and divide by 1 plus x, so 1 plus x by 1 plus x square, so I add the numerator 1 plus x minus the second term in the denominator is same, the LCM term in the second term, so no changes, so only I write the numerator minus 1, so 1 plus x minus 1 by 1 plus x whole square, so plus 1 minus 1 cancelled, so x by 1 plus x whole square. Now I take the f dash of x equal to 0, so f dash of x equal to 0 means x by 1 plus x square equal to 0, so this term equal to 0 means x equal to 0, so therefore the stationary point is x equal to 0. So the next step, now I represent the critical point in the number line, so minus infinity comma 0 and 0 comma infinity is the interval, therefore I make it the table intervals sign of f dash of x and the monotonicity. So first I take the interval minus infinity comma 0, here minus infinity will come, so minus infinity comma 0 and minus, so minus infinity comma 0 means all the values are negative values, so I substitute negative values in the f dash of x, I get the answer negative answer, so strictly decreasing. Next is 0 comma infinity, 0 comma infinity means it is a positive answer, I substitute positive answer in the f dash of x, I get the answer positive, so strictly increasing. Therefore from this table I conclude that but x equal to 0, f dash of x equal to 0, f dash of x is strictly decreasing and x less than 0 and strictly increasing for, that means from this table I conclude that that means f of x is strictly decreasing on minus infinity comma 0 and strictly increasing on 0 comma infinity. So next one, the sign changes, from minus to plus at the point x equal to 0, this, so x equal to 0 is this is a local, minus to plus means it is a local minimum, so local minimum at the point x equal to 0. Now we find out the local minimum value, so we take f of 0 equal to log of 1 plus 0 minus 0 by 1 plus 0, so log 1 is 0, so 0 minus 0 is, the answer is 0. You see f of log 1, the final answer is log 1 value is 0, f of 0 equal to 0, so 0 is the local minimum, therefore local minimum value is 0. So next local minimum equal to 0, therefore next x greater than 0, so log of 1 plus x minus x by 1 plus x greater than 0, log of 1 plus x greater than x by 1 plus x, so therefore the domain is 0 comma infinity. we find out all the answer. They ask about in this problem they ask about monotonicity and local extrema and domain. Everything we find out. These three answers we find out from this problem. Next problem, example 7.54. Find the intervals of monotonicity and local extrema of the function x log x plus 3x. So for here in this problem they ask about intervals and next local extrema. So first I write the given function f of x equal to x log x plus 3x, x belongs to 0 comma infinity. So now I take the differentiation derivative f dash of x equal to, now you see the first term there is a two function. First function is x, there is a two factor, one is x, another one is log x, two functions. So we apply the UV method, differentiation of UV. We know the differentiation of UV, that means differentiation of d of UV means u into dv plus v into du. So first I write the given function as it is. Next I differentiate the second function. So differentiation of log x is 1 by x plus second function I write and write it as it is. First function I differentiate, differentiation of x is 1 plus 3 into differentiation of x is 1. So x cancelled, 1 plus log x plus 3. So 1 plus 3 4, 4 plus log x f dash of x. So in the next step I take f dash of x equal to 0. So 4 log x, 4 plus log x equal to 0. Log x equal to, I write this 4 in the right hand side, so minus 4. So in the next step I write it, that means I take the exponential on both the side. So e power log x equal to e power minus 4. So exponential and the log cancelled, x equal to e power minus 4. So the stationary point, now in this x value is the stationary point, therefore the stationary point is x equal to e power minus 4. Therefore I represented this stationary point in the number line. So the number line is 0 to infinity. I started from 0 to infinity because they give the interval here. This log functions it lie in the 0 to infinity. So 0 e power minus 4 infinity. So the interval is 0 comma e power minus 4 and e power minus 4 comma infinity. So now I write it the f dash of x equal to 4 into 4 plus log x. Now I make it the table. First column interval, second column sign of f dash of x, third column monotonicity. So interval means we find the two intervals 0 comma e power minus 4 and e power minus 4 comma infinity. So I substitute any value from this interval in the f dash of x, I get the answer minus answer. So I represented the sign minus. So therefore minus sign means I represented, I write it strictly decreasing. And next any values I take from e power minus 4 this interval. So that values I substitute f dash of x, I get the answer plus answer, plus that means plus answer. So therefore plus means it is a strictly positive answer, I get the answer positive answer, so strictly increasing. So from this answer I conclude that f of x is strictly decreasing on 0 comma e power minus 4 and strictly increasing on 0 comma e power minus 4. So f dash of x is changes from negative to positive, sign changed from negative to positive. So we get local minimum. So we write it when passing through x equal to e power minus 4. So f of x has local minimum, minus 2 plus means local minimum, plus 2 minus is local maximum. So local minimum at x equal to e power minus 4 and local minimum value is, so local minimum at the point x equal to e power minus 4. Now we find out the local minimum value. So f of e power minus 4 equal to, you substitute the function x equal to e power minus 4, e power minus 4 log of e power minus 4 plus 3 e power minus 4. Therefore e power minus 4 log e cancelled, so minus 4 plus 3 into e power minus 4. So minus 4 e power minus 4 plus 3 e power minus 4. So we add that, we get the answer minus e power minus 4. So therefore local minimum equal to minus e power minus 4. This is the answer for this problem. So in this problem they ask about the question is find the interval and monotonicity and the local extrema. So everything we find out. You see the example 7.55. Find the intervals of monotonicity and local extreme of the function f of x equal to 1 by 1 plus x square.